Welcome to the Unit 6 test review. Today I'll be going over all the questions that you will be taking for this test. We won't be using all of the questions on the test. You should be using this review before the test and, if possible, changing some of the numbers on these questions to get some extra practice in. The first question we'll be doing is number 2. Number 2, we've seen these problems before, is asking you to put the letter of the problem in the correct box that matches the answer. So you're going to be starting with A. You're going to find the answer to A, and the answer is going to be either 52, 5 2/10, or 52 hundredths. When you figure out which of these answers is correct, put the letter A in one of these three boxes. This is a mental math problem. You should be able to solve these questions without doing any arithmetic. Simply moving the decimals is all you'll need to do. We're dividing here, and we're dividing by powers of 10 for each and every one of these numbers. So if I were to take a number such as 32 and divide it by 10 to the first power, we're simply going to do the opposite of what we would be doing if we were to multiply this by 10 to the first power. And we did that in the last unit. We showed that we would take our decimal. First, we would have to show our decimal since there isn't a decimal on 32. So we would bring our decimal out, and then when we were multiplying, we would move the decimal to the right, however many number of tens we had, and the exponent tells us that there's only one 10. Because we're dividing now, we're going to be doing the opposite. So we'll take our decimal again and move it, though, instead of to the right, to the left, because we're dividing. This should make sense because when we're finished moving it one time to the left, because there's 1 10 or 1 0, when we're finished moving it one time to the left, we end up with 3 2/10. That should make sense because we started with 32 and we're dividing by 10. And when you're dividing by a number, you would expect that the answer, the quotient, if you will, would be smaller than what you started with. And 3 2/10 is smaller than 32. Let's look at another problem here, one that already has a decimal in it. Here we have 3 2/10 divided by 10 to the second power. 10 to the second power, as we know, is 10 times 10. 10 times 10 has 2 zeros in it. 10 times 10 is also equal to 100, which has 2 zeros. But this exponent is really all you need to tell you how many zeros you're going to have and how many times you're going to move the decimal. So here we're dividing, which means that we're going to be moving the decimal to the left 2 times. In order to do that, we're going to need to add a 0. And then we're going to place our new decimal right before. So our new answer is going to be decimal 032. So for each one of these problems, you're just simply going to be moving the decimal to the left. And since none of these actual problems have decimals in them, they're all whole numbers, 52, 520. All of them are 52, 520, or 520, 5200. None of those have decimals. So you're going to have to bring the decimal out first, which means that you're going to be adding the decimal where it belongs. Where does the decimal go if there is no decimal? That's right, you put it at the end. At the end of a whole number, a decimal will not change the value of the number. This is still 52. This is 520, and if I add the decimal at the end, it's still 520. Think of it like money. This is $52, and if you add the decimal, even if you add a couple of zeros, it's still $52. This could be $520 or 520, and adding the decimal at the end doesn't change the fact that it's 520. If you were to put the decimal anywhere else, it would change the value of the number. So you have to remember to make sure that your decimal is in the correct location, and that would be at the end of the whole number. Question number 3 asks you to explain why 3 6/10 divided by 4 hundredths has the same answer as 360 divided by 4. In order to answer this question properly and to explain it, you have to understand what we did to this problem to make it equal to that problem. So I'm going to give you a new problem. Here we have a new problem. It's 27 4/10 divided by 5. You know that in order to solve this problem, you have to move the decimal on the divisor one time to the right in order to get rid of that decimal, and then that 5/10 becomes 5. And when you know also that whatever you do to the outside, you must do to the inside. So we're going to take our decimal here and we're going to move it one time to the right as well. And that decimal now is at the end of the number where it no longer needs to be seen. And our new number is 274. We've seen this before. We know that when we move the decimal one time to the right, as we did on the divisor, that anytime you move a decimal one time to the right, what you're really doing is multiplying by 10. That has 1 0. You're multiplying, that means you're going to move the decimal to the right to make the number larger. And we're moving it one time, which is the equivalent of 1 0, which makes it the equivalent of 10. When we multiplied the outside number, or our divisor, by 10, we had to do the same thing to the inside number. We had to rotate this decimal one time to the right as well, which means we multiplied the dividend by 10 as well. So in the problem that I'm showing you here, what we basically did was multiplied both the inside and the outside number, both the divisor and the dividend, by the same number, 10. Therefore, we kept the problem equivalent. It's balanced. It's really the same problem. As long as we do the same thing to the inside as the outside, it's the same problem. You need to figure out what you're going to have to multiply the original problem by, what we have to multiply the divisor by here to get rid of the decimal, and what do you multiply the dividend by on the inside. It would be the same. You should be multiplying by the same number. But your explanation will be just that you're multiplying both the divisor and the dividend by the same number. You'll need to tell me what that number is. Next question we're doing is number 5. A farmer ships 4 times as many oranges as tangerines. The farmer ships 8,260 oranges. How many tangerines does he ship? I would like you to write the equation and then solve. I made an adjustment to the problem, and now the farmer is shipping 2 times as many oranges as tangerines. And the farmer ships 40 oranges. So how many tangerines is he shipping? We need to figure out a formula, a mathematical equation that we can write so that we can solve it. So I've written here an equation that will help us solve this. And I want to show you what this equation means because you'll have to write one for yourself, for your problem. So here I have t times 2 equals 40. Well, the t stands for tangerines, and I don't know how many there are. That's what I need to figure out. How many tangerines did he ship? So my goal here is to get this t by itself. So I have t equals some number. I know that the farmer shipped twice as many oranges as tangerines and that he shipped 40 oranges. So I know that if I knew how many tangerines he shipped, if I multiply that by 2, it will equal 40. I know that he shipped 40 oranges. So I know that 2 times the tangerines, or 2 times the tangerines, equals however many oranges, which is 40. How do I get t by itself? Here we're going to have to use a little algebra. We want to try to isolate the t, so then to do that if we could just get rid of this 2, we would have t all by itself. And in order to get rid of that 2, we just simply do the opposite. So we look to see what we're doing to the 2, which is multiplying by 2. So we're going to do the opposite of that and divide by 2. And I just show that underneath it because I'm just going to cancel those out. And now I've gotten rid of the 2, and I'm stuck with just t over here with an equal sign. Now, of course, whenever we're dealing with math, we have to keep equations balanced. So we can't just divide one side by 2 and not do anything to the other side. So if we're going to divide this side by 2 in order to get rid of this 2, then I need to do the same thing to the other side. So I'm going to divide 40 by 2. That could be shown by using this equation. or I could even just draw a line under 40 and divide it by 2 that way. And now we have t equals 40 divided by 2, which is the same thing as t equaling, we can now solve this, 20. And now we can plug 20 in for t and see if this equation is correct. 20 times 2 equals 40. That equation is correct. So t then therefore must equal 20. You'll be using the same formula to solve the original problem. We're solving number 6 as well. Jamal buys postcards of Washington, D.C. for $10.20, not including the tax. Each postcard cost 85 cents. How many postcards does Jamal buy? Your first job is to figure out whether you're multiplying or dividing. One way to try to figure out whether you're multiplying or dividing is to make the problem a little simpler. Get rid of the decimals and make it some nice and round number. Let's say Jamal buys postcards of Washington, D.C. for $20. And that each postcard costs $5. Now how many postcards could he buy? If you were buying postcards and they were $5 a piece and you bought $20 worth, how many would you have bought? If you said 4, you're correct. How did you get that 4? In order to get 4 with the numbers 20 and 5, you would have to divide. And that's what you should be doing with the original problem. Of course, you're going to be dividing with decimals, and that makes the problem more difficult. You will have to remember that when dividing by decimals that you need to move the decimal from the divisor. That has to be moved. And then you're going to have to do the same thing to the dividend, as we showed earlier in this review. You're really going to be multiplying the outside and the inside numbers by the same power of 10. You may think of it either way you want, but the reality is both things are true. You're moving the decimal on both of these numbers, but at the same time, to move that decimal, you're really multiplying it by a power of 10. How many times would you have to move the decimal on the divisor in this problem to get rid of it? However many times you choose, make sure you do the same thing to the dividend on the inside. We're also doing number 7, and number 7 is asking you to find the missing side. And so what you need to do here is be aware of what the formula for area equals. It equals length times width. And then you're going to plug in the numbers that you know. We know the area, so we can plug that in. We know this side, which could be the width. I'm going to make that the width. You could call it anything you want. I'm not going to label it. I'm going to leave the label off of that. So now we have our equation rewritten because we know a couple of the numbers, and now we only have one number that we don't know, and that's the length. And now we go back to a few problems earlier where we need to use algebra in order to get rid of what is over here so that we can have L by itself. In order to get rid of times 14, we take what we're doing to this 14 and we do the opposite. So you should be dividing by 14, and you can show that underneath a division sign because it's just going to cancel. There's no math to do there. We just want to show what we're doing. And then whatever you do to this side, you must do to the other side. So if we're going to divide this by 14, you could do that by drawing the line. That's could be a fraction line, but also means to divide by. And now you have a math problem over here. 95 and 9/10 divided by 14. And that should be rewritten 95 and 4/10 divided by 14. No decimal in the divisor, so you don't have to move any decimals. So you can just bring your decimal straight up and go to work. Question number 8. Mr. Adams dividing his markers equally among 26 students in his class. He puts the extra markers in a box. What's the least number of markers he puts in the box? In order to solve this problem, you're going to need to solve a division problem. We have 223 markers that he's dividing equally amongst 26 students, and you could just start writing your division problem already. You need to solve this problem to see how many markers each student is going to get. And you're going to have some markers left over, and those leftover markers he's going to put into a box. So your job is to find out what the remainder is. Once you have the remainder, you have the answer. That's the number of markers that are left over and the number he'll put in the box. Number 9, if you are in a park and it's creating habitats for 182 monkeys, each habitat can only hold 8 or fewer monkeys. The question becomes, what's the least number of habitats that the zoo is going to need? So you're in a zoo, you got to create space for monkeys. You have 182 of them, and each space you create can only hold 8. So what's the least number of habitats that you will need? So you're dividing your 182 monkeys into spaces, and the spaces hold 8. So again, you're dividing 182 monkeys up into groups of 8 so that you can put them in their habitats. It's very unlikely that when you're finished with this, you'll end up with no remainder. You may have a monkey left over, or 2 monkeys left over, or you may have up to 7 monkeys left over. You should not have 8 or more monkeys left over. If you have 8 or more, then you should have built another pen for them. So the answer would become your quotient up here. But then if you have any monkeys left over at all, you would have to build another pen for those monkeys. You can't have monkeys left over that don't have a place to live. And even if you only have 1 monkey left over, he's got to have a place to live, and you'll have to create another space for that monkey. And the answer becomes whatever your quotient is up here, plus perhaps 1 more if you have anything left over, because the number of habitats you need would be the number you have in your quotient up here. And now if you have any monkeys left over, you're going to have to build an extra habitat for them. So add 1 to your quotient if there are any leftovers.